Okay, so let's take a look right now what's in Schoology. Um, just to let you guys know, on today we are starting a new topic. We are going to be talking about energy. We're going to be spending a couple weeks talking about energy, and then we're going to be spending a couple of weeks talking about momentum and impulse. So that's the goal for the next few weeks. Okay, so um, if you click on the class folder, the materials tab. Okay, we're in the fifth 6 weeks, and of course today is April the 12th, and it is a Monday. Okay, so the goal for today, we're going to go over this PowerPoint that I have in Schoology, titled the Energy PowerPoint. As I said, today we're going to be focusing on the various types of energies. Um, And then we're going to look at a few problems from this PDF file that says energy calculations and concepts. We're going to go over a few things as a class. You do not need to write anything. As soon as we're done with this, going over these concepts, you guys should be ready to do this assignment in Schoology by yourselves. And of course, I'm going to open that up for you all as soon as class is over. So that is the goal for today. We're talking about energy. Okay. For those of you guys who are just now coming in, please fill out the attendance form. Okay, so let's start with going over the PowerPoint. Let me go ahead and pull that up. Okay, so on today, we're going to focus on the three main forms of energy that you're going to see in Physics 1. The first is what is known as gravitational potential energy. We're going to focus on this. Then we're going to talk about kinetic energy. Then we're going to talk about elastic potential energy. Okay, it's our third form of energy. So these are the three forms of energy we're going to talk about on today. Okay. Um, let's start with gravitational potential energy. Okay, what is gravitational potential energy? It is energy of position due to gravity. Any object above the ground or on a ledge has potential energy. Okay. Um, kinetic energy, on the other hand, is referred to as the energy of motion. Okay. But going back to this potential energy right here, gravitational potential energy. So we call it potential energy because it's stored energy. It's energy that an object has stored within it as a result of the object's position. Let me show you guys an example of what I mean. Guys, consider this ball here. Okay. So, um, so this ball in my hand. Okay. Um, guys, this ball in my hand. Right now, as this ball is sitting above the surface of the earth, it has gravitational potential energy. Okay. If the ball was on the ground, like it was just sitting on the ground, it would have zero potential energy. It would have no potential energy at all. Um, how is it that I know that this ball has potential energy just by me just having it some height above the surface of the earth? Well, it should be obvious to you guys, because if I take this ball and if I release it, notice what happens. The ball accelerated downward. Um, the ball accelerated downward. In other words, the moment I release the ball, I allow the object to have kinetic energy, right? So potential energy at the top became kinetic energy in the ball. In fact, that's why we call it potential energy, because it has the potential to become kinetic. So the point is that I'm getting at, the act of me holding this ball above the surface of the earth gives it potential energy. Because of gravity, because there's a gravitational field surrounding the ball, I know this ball has potential energy because the moment I release it, notice the ball immediately starts moving. So it has the potential to become kinetic. That's what we mean by when we say potential energy. Specifically, if we're talking about gravitational potential energy. Gravity stores energy in the ball. Um, uh, by the simple fact of me lifting the ball to some height above the surface of the earth. Okay, so hopefully that makes sense. Okay, going back to the PowerPoint. I want you guys to know the equation for gravitational potential energy because these equations are going to be important in the coming days. Um, if you notice here in the PowerPoint, it says gravitational potential energy is equal to m times g times h. So I'm gonna write that down. Gravitational potential energy an object's gravitational potential energy is equal to an object's mass times g times height. Okay. Whereas understood here that little g is the constant 9.8. Okay, meters per second squared. So 9.8 meters per second squared is always the constant that gets plugged into this equation. So if you want to know an object's gravitational potential energy, you just multiply its mass times 9.8 times whatever height it is above the surface of the earth. Okay? And just to be clear, guys, the standard unit for energy is the joule. Okay, energy is always measured in joules. So this equation is going to be important in the coming days whenever it comes to measuring energy. Hold on, guys, give me just a second. Okay, so now that we know what gravitational potential energy is, let us move on to talking about kinetic energy. Now, if potential energy is an object's stored energy, and specifically gravitational potential energy is stored energy as a result of an object's height, kinetic energy is by definition the energy of motion. So any object that is moving has kinetic energy, which obviously means that an object at rest has no kinetic energy at all. So if it's moving, it has kinetic energy. Now, the equation for kinetic energy, I'm going to write this down. You guys to know that the equation for an object's kinetic energy is equal to 1/2 times the object's mass times its velocity squared. So let me write that down just so you guys will have that in the back of your mind. The equation for kinetic energy is 1/2 times the object's mass times the object's velocity squared. So any object that is in motion always has kinetic energy. And again, please remember your units. The units for energy are in joules. The units for mass are in kilograms, and the units for velocity are in meters per second. So this is the equation for kinetic energy. Okay. And lastly, the last thing that I want to talk about for today is another form or another type of potential energy, and that is what is known as elastic potential energy. Elastic potential energy comes from springs or elastic objects that push when compressed or pull when stretched. So basically, guys, elastic potential energy comes from any object that has some sort of elasticity to it. It can either be stretched or compressed. So let me give an example of what I mean by this. So guys, in my hand here, I'm holding a rubber band. Okay. As I take the rubber band and I stretch it, I've given the rubber band elastic potential energy. So the act of me stretching this rubber band stores energy within this system or within this object. Can someone tell me, how do I know that the act of stretching the rubber band causes potential energy to be stored in this system? How do I know it? Because what's going to happen the moment I release this rubber band? So the moment I let go, what will happen? Can someone tell me the moment I let this rubber band go, that energy gets transformed into what? What do y'all think? How do I know that
Kinetic.
I'm sorry?
Wait, you said? Can you say it again?
Yeah, so the moment I stretch this rubber band and I let it go, what's going to happen?
It starts to move.
Starts to move. So in other words, what is being produced?
Kinetic energy.
Kinetic energy. Bingo. So the, so that's how we know that the act of me stretching this rubber band stores energy in the rubber band. Like I've given this rubber band elastic potential energy by stretching it. Because guys, exactly as Jeremiah said, the moment I take this rubber band and the moment I let it go, it's gonna fly off in that direction. Right. So in other words, that potential energy will become kinetic energy at the moment I release it. That's what we mean by when we say potential energy, the potential to become kinetic. In this case, I'm dealing with elastic potential energy, stored energy in the object, where, as I take this and I release this, the potential energy goes away, and that energy and that kinetic energy is being produced right at the second that I let it go. Okay, and before I move on from the PowerPoint, let me give you guys the equation for elastic potential energy. So the equation for elastic potential energy, let me write down this equation. So an object's elastic potential energy is equal to 1/2 times k times x squared. K is what is known as the spring constant. Basically, it's a measurement of the stiffness of the material. Different objects have different constants, and you will be given that if you guys have to use this equation for a particular problem. Um, x x is known as distance. It basically refers to the distance stretched or compressed. So if I stretch this rubber band so many centimeters, or in other words, so many meters, if I know the precise value that I stretch this rubber band in meters, then I can just plug that into this equation for x. Okay. So once we plug that in, that will give us an object's elastic potential energy, which is equal to 1/2 times the spring constant of the object times the distance squared. Okay, so that's how you find elastic potential energy. All right. Any questions on the PowerPoint? And again, that PowerPoint will be in Schoology. Guys, before we look at that PDF file for today, let me just go over a few things. So, guys, I want you guys to take this guy here who's on this skateboard right here, and he's going down this ramp. So I want you guys to notice something. The moment I release this guy from this ramp, notice what happens to the kinetic energy and the potential energy off to the side. So, all right, can y'all see what's happening here? And again, we're assuming there's no friction here, so we're ignoring friction. Okay. So notice what keeps happening to the kinetic energy and the potential energy. Okay. Notice when the guy's at the very top, he has his most potential energy, and that makes sense, right? Because he's high above the surface of the earth, so he has the most potential energy here. But as he goes further and further down, at the bottom, that's where he has his most kinetic energy, because there he's moving the fastest. And obviously, as he goes up, he slows down to a stop, therefore giving him potential energy again. So as we play this in slow motion, notice um, um, how as potential energy decreases, kinetic energy increases. And as kinetic energy decreases, potential energy increases. So we kind of clearly see that happening here. Again, the most kinetic energy is at the bottom. Here he's moving the fastest. And as he goes to the top, he slows down, comes to a stop, therefore giving him zero kinetic energy here and having all potential energy. And of course, if we ignore any outside forces, such as friction, basically this system will keep going like this forever. Well, the potential energy gets converted to kinetic energy, back into potential energy, and so on and so on and so on. Okay. So hopefully this bar chart helps everyone make sense of what's happening to the potential energy and the kinetic energy of a system as our system evolves over time. Okay, kind of what we see here with the skateboarder. Okay. Um, so with that said, let us open up this PDF file here that's titled Energy Calculations and Concepts. And again, we're just going to go over a few things as a class. You do not need to write down what I'm writing down, but I want you guys participating with me because I want you guys to have enough knowledge to be able to do this assignment yourself. Okay, I'm not going to go over every single one of these sections with you all. I'm just going to go over enough so that you guys can get the point. Let's look at this first section right here. So in the first section here, you guys are matching the letters with the numbers. Okay, I want you guys to walk me through this. Okay, so guys, look at number 1. And someone tell me in the chat box which letter A, B, C, D, or E is going to go next to number 1. Which one matches up with the definition? Yep, C matches up with number 1. Thank you. It's the energy of motion. Okay. Guys, what matches up with number 2? Yes, number 2 is D. Exactly. Thank you, guys. Number 3? Yes, Angelina, B. Exactly. Thank you, Jeremiah. 4? What matches with number 4? Mm-hmm. Yep. Which obviously means 5 must be. Yes. 5 is A. Thank you, Angelina. 5 is A. It is the unit. Joules is the standard unit for energy. Okay. All right, let's keep going. Let's look at this section right here where it says basically you're going to label each situation, whether or not it's potential energy or kinetic energy or even both, depending on the situation. Okay. So if you look at number 1, if you see a car is traveling at 45 miles per hour, and obviously the car is traveling along the ground, in that case it has no potential energy, but it does have kinetic energy because it's in motion. So I'm going to put KE there for kinetic energy. A rock is on a ledge 5 meters high. So notice the rock is high. It's above the surface of the earth. So here, that's where we're dealing with potential energy. Okay. A car is resting at the top of a hill. So it's resting. So obviously it has no kinetic energy. But it's at the top of the hill, which means it must have potential energy. Okay. What about this one? This is interesting here. A ball is thrown in the air and it's still moving. So guys, it's in the air, but it's still moving. So in this case right here, it should be obvious to you guys that we have both kinetic energy and potential energy here, right? How do we know it has both? Well, it has potential energy because it's in the air. Obviously, it's not on the ground. It's in the air, so it has potential energy. But notice it says it's still moving. So as long as it's moving, it also has kinetic energy as well. A ball rolling on the ground. So if the ball is rolling along the ground, it's on the surface of the earth. So that means it has no potential energy. It just has kinetic energy. Any questions there?
Nope.
All right. All right. Let us keep going. So let's look at these 2 sections right here. It says circle the one with more potential energy. Okay. So What has more potential energy, a 25 kilogram mass or a 30 kilogram mass at the top of a hill? So obviously the one with the greater mass has the most potential energy. What has the most potential energy, a car at the top of the hill or a car at the bottom of the hill? Remember, the higher it is, the more potential energy it has. What has more potential energy, a plane on the ground or a plane in the air? If it's in the air, it has the most potential energy because it has height. What has most potential energy, a full plane or an empty plane? Both are flying. Obviously, the full plane, right? Because the full plane has more internal mass than the empty plane. So it has more potential energy. Now, right here it says circle the one that has the most kinetic energy. So a 25 kilogram mass or a 30 kilogram mass, both moving at 5 meters per second. Well, if they're both moving at the same speed, the greater mass should have the most kinetic energy. Okay. So two 10 kilogram cars, one going at 75 meters per second and one going at 45 meters per second. So obviously the one that's moving the fastest has the most kinetic energy. Okay. A car at rest or a car rolling down a hill. Okay. So if it's rolling down a hill, it has kinetic energy, but if it's at rest, it has zero kinetic energy. A heavy bike or a light bike, and again, I'm assuming they're both in motion. So in this case, it would be the heavy bike that has the most kinetic energy. All right, guys, the last thing that I want to do on today, I just want to close out with this section here. I just want to close out practicing with a few of these equations. So let's look at this first one right here. It says a 4 kilogram rock is rolling at 10 meters per second. Find its kinetic energy. Okay. Well, you guys know the equation for kinetic energy is equal to 1/2 times mass times velocity squared. So in order to calculate kinetic energy, guys, you would just simply do this. So kinetic energy, okay, 1/2 is the same thing as 0.5. So 0.5 times 4 kilograms for the mass, and velocity gets squared, so 10 squared. Okay. So guys, what do y'all get when y'all put in your calculator? What's 10 squared times 4 times 0.5? Anyone want to tell me? Or you did it in your head? Thank you. 200 joules. I always put your units 200 joules for your kinetic energy. Okay. Okay, let's look at the other one right here. So it says, calculate the potential energy of a 10 kilogram rock at the top of a 6 meter tall table. So here we're dealing with gravitational potential energy. So I'm going to write down my equation for gravitational potential energy, which is mass times 9.8 times height. Okay. So let's plug everything in. Okay, so in this case right here, the mass is 10 kilograms. Y'all, little g in this equation is always 9.8 here on Earth. And the height is 6 meters. Anyone want to give me the answer there? 10 times 9.8 times 6. What do y'all think? Thank you. 588 joules. Thank you, Angelina. Yes, as long as we're solving for energy, it's in joules. Exactly. Okay. Let's keep going. Again, we just want to finish up this section here. An 8-kilogram cat is running at 4 meters per second. Find the cat's kinetic energy. Kinetic energy is 1/2 times mass times velocity squared. Remember, 1/2 is the same thing as 0.5. The cat's mass is 8 kilograms. And we see that it's running at a velocity of 4 meters per second. So 4 squared. So guys, 4 squared times 8 times 0.5. Turns out it gives me 64 joules. Find the potential energy of a 2-kilogram ball, 15 meters in the air. So guys, in this case right here, we're moving backwards. No, I'm sorry. No. Wrong problem I'm thinking of. No, so we're just using our gravitational potential energy equation, which is mgh. So the mass is 2 kilograms, g is 9.8, and the height is 15 meters. When we do 2 times 9.8 times 15, we get 294 joules of potential energy here. Specifically gravitational potential energy. All right, let's keep going. A rolling ball going at 3 meters per second has 18 joules of kinetic energy. Find its mass. So guys, in this case right here, now we're moving backwards where they give us the kinetic energy and now they're going to ask us to solve for mass. So they tell us that it has 18 joules of kinetic energy. And we want to know, well, and we know that the velocity is 3 squared. Okay, so 18 times 1/2 times mass times 3 squared. Okay, so the goal, guys, is to get mass by itself. That's really the goal here, is to get mass by itself. So how are we going to do that? So in order to get mass by itself, what I'm going to do, I'm going to take 3 squared, which is 9, and multiply that by 1/2. In other words, multiply that by 0.5. So 3 squared times 0.5 gives me 4.5. So I'm just going to take this equation here and simplify it to 18 equals 4.5 times mass. Last thing that I want to do here, guys, how do I solve that equation for mass? I would just do what? How do I get m by itself? Guys, on the right side. Yes, thank you, Stephanie. I will divide by 4.5. That goes away. Whatever to the one side, I have to do to the other. So my mass, if I take 18 and divide it by 4.5, I get a mass of 4 kilograms. All right, guys, hopefully that makes sense. All right, guys, we have two more to do. A box is 4 meters in the air and has 120 joules of potential energy. What is the box mass? Okay, so once again, we're using our equation for gravitational potential energy, which is equal to mass times 9.8 times height. So we know we have 120 joules of potential energy. We don't know the mass. That's what we're trying to find. But we're given that the height is 4 meters. Okay. So guys, the goal here is to get m by itself. First thing I want to do 9.8 times 4. When I do 9.8 times 4, what does that give me? So if I do 9.8 times 4, that gives me 39.2. Yep, and then divide by 39.2. Thank you, Angelina. That's what I was just about to ask. On both sides to get the mass. And when you do, I got a mass of 3.06 kilograms. Yes, Angelina, that would be the specific value, the exact value. You're right. All right, last one. This last question says a 4 kilogram bird has 8 joules of kinetic energy. How fast is it flying? In other words, guys, we are solving for velocity. We are solving for velocity here. So kinetic energy is equal to 1/2 times mass times velocity squared. Okay. Now let's just plug everything in. So he's flying with 8 joules of kinetic energy. You know what? Let me write down 0.5 for 1/2. So 0.5 times 4, which is the mass of the bird, times v squared. Now the goal there is to get the velocity by itself. First of all, 1/2 of 4, that's just 2. So this just becomes times v squared. Okay. Remember, the goal is to get velocity by itself. So what I would like to do here, I would like to divide by 2. That goes away whatever once I have to do together. So 8 divided by 2 gives me 4 is equal to v squared. And then lastly, guys, what do you do to get rid of a squared? You take the what? Yep, the square root. So the square root of 4 gives me v. In other words, my velocity is, yes, Angelina, thank you. My velocity is 2 meters per second. Any questions on what we did here? Any questions? Okay, so the goal today was just to introduce energy, the concepts, go over a few mathematical problems. The assignment that I'm going to post in Schoology mainly deals with concepts, when I see you guys on next class period, we're going to get more involved with this equation as far as the assignment that you guys have to complete for that day. But for this right here, this assignment just for the day just focuses pretty much on concepts. But of course, I do expect you guys to know how to use this equation in the future. The reason why I went over some examples on today. Okay. So let me go ahead and make this visible to you guys. So the assignment should be available for you guys if you have not seen it yet. Also, for those of you guys that did not get a chance to do so, I'm going to put the attendance form in the chat box again. Please click on that attendance form and get that filled out. All right, guys. If there are no immediate questions for me, you guys are free to go. Remember, the Zoom call is going to be open up until 3:20. Have a good day, everyone. Bye, guys.